Hello everyone, welcome to Explore Hop. So for this example, we're told that you roll a four-sided die 2 times. Then we let A be the event that the first roll is a 2, and B be the event that the maximum of the two numbers is 2. Are events A and B independent? So let's first determine the sample space of this experiment. We can first create a tree diagram to visualize all possible outcomes. So this is what the tree diagram looks like. And from here, we get that the sample space is therefore the set containing the outcomes 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, 2, 4, 3, 1, 3, 2, 3, 3, 3, 4, 4, 1, 4, 2, 4, 3, and 4, 4. So this is the sample space of this experiment. Now, from the sample space, we can see that there are 16 possible outcomes. And now, let's find the probabilities of event A, B, and the intersection of event A and B. So to find the probability of event A, which is the probability that the first roll is a 2, we simply take the number of outcomes where the first roll is a 2 and divide it by the total number of outcomes in the sample space. So we can see from the sample space that the first roll is a 2 over here, the first roll is a 2 over here, the first roll is a 2 over here, and the first roll is a 2 over here. So that gives us 4 outcomes where we have a 2 as the first roll. So therefore the probability of event A is equal to 4 over the total number of possible outcomes, which is 16. And this is equal to 1/4. Likewise, to find the probability of event B, which is the probability that the maximum of the two numbers is 2, we just take the number of outcomes where the largest number is 2 and divide it by the total number of outcomes. So we see that the largest number is 2 in this outcome over here. The largest number is 2 in this outcome over here. The largest number is 2 in this outcome over here. And that's all of the outcomes where the largest number is 2. So therefore the probability of event B is equal to 3 over 16. And now to find the probability of the intersection of event A and B, we simply take the number of outcomes where the first roll is a 2 and the largest number is also a 2 and divide it by the total number of outcomes. And we see that the first roll is 2 and the largest number is 2 in this outcome over here. The first roll is 2 and the largest number is 2 in this outcome over here. And therefore the probability of the intersection of event A and B is equal to 2 over 16, which is equal to 1 over 8. Now we can go ahead and find the probability of B given A, which we know is equal to the probability of the intersection of A and B divided by the probability of A. And this, of course, is therefore equal to 1 over 8 divided by the probability of event A, which is equal to 1 over 4. And this is equal to 4 over 8, which is equal to 1 over 2. And that gives us the conditional probability of B given A. Now, if we compare the conditional probability of B given A to the probability of B, we can see that they are not equal. So we can see that the probability of B is not equal to the probability of B given A. since 3 over 16 is not equal to 1 over 2, which therefore means that events A and B are not independent of each other. So events A and B are not independent. Which means that they are dependent. So events A and B are dependent. And that's it for this example. Thank you for joining us. See you in the next lesson.